Right, streaming, I think. So this is a draftphysics.com, debatephysics.com video presentation. And somewhere in here I'll find the video I'm replying to. And so it's this guy and gal being all voguey and edgy, doing whatever, science-tainment, talking about gravity. So I haven't played the video, just played the beginning, and it starts with crap right from the start because they've titled the video something stupid about pushing. Yes, we're all being pulled together. No, you're not being pulled together. You're being pushed together. And it does feel like that, frankly. Yes, it does feel overcrowded and pushy. Here on Earth, anyway. It feels push-aversy. But anyway, so they got it all wrong, of course, and so I will point out all of the wrongs. So they first do this silly commercial for cancer research. So pleasant. It's just lovely to think about cancer for no good reason, except they're paying you to do it. Gross. Anyway, so yeah, it starts all wrong for me, personally. But anyway, let's see, is there anything else to say? Yeah, I don't think so. So we'll just see how it goes. I believe there's enough volumes and such. Really should be loud enough, so.
And welcome to The Rest is Science. I'm Michael Stevens.
And I'm Hannah Fry.
And
so it's ding 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 ding. Whatever. Deliverance and what do you call the orange people? There's a name for them, but fine.
Today, I'm asking you, Hannah, when was the last time you fell over?
I mean, I fall over quite a lot, I've got to be honest with you. I think my limbs are longer than my brain expects them to be, so I get myself in all kinds of trouble. I think probably the most notable time was I was walking home quite late at night, and there was a big queue for a nightclub. And at that moment, a really interesting car drove past. I was so busy looking at the car that I walked into a lamppost and then fell over backwards. And everyone in the queue saw me do it.
Right, but it's less embarrassing than wearing his his beard for a day, right? What would be more embarrassing? Yeah. 10 seconds of falling down or having to wear that beard all day.
It was not a good day.
You're a lucky duck. Because that means you got to experience weightlessness.
What, on the way down? Is that how you should think about it every time you fall over?
That's how you should think.
So again, you're not weightlessnessing. All you're doing is sitting in a differential, in a force differential. There's more force, there's more river flowing down than there is flowing up, and you move in the differential. There's more wind, there's more paint, there's more sand, there's more anything I could throw, and you're just moving in the differential. But you're not weightless. You're gaining velocity. Every little inch you fall is a moment of time, and in units of time, you'll keep collecting velocity.
You're a lucky duck.
That's how you should think about gravity.
You can't feel gravity because, unlike the other forces that sort of interact with your surface, gravity doesn't bother with your surface. It bothers with your electrons and your protons. So your electrons and protons don't react like a photon. They don't capture because it isn't energy in some sort of pattern. And the lack of a pattern means that it permeates you and pushes everything the same. So you can't feel gravity pushing you, but that's what it's doing. And even if you believe this silly pull crap, obviously you don't feel the pull. You feel impacts. Yeah, you don't feel the force applying the momentum.
Which is what I want to talk about. Gravity is one of those things that we all experience constantly, can't get away from it, and yet, what the heck is it?
What?
Right, and the simple answer is it's just a force differential. There's whatever it is, and I'm arguing it's just the same crap that the background radiation is made out of, same crap photons is made out of, same crap that's all going the speed of light, and there's a ton of this stuff. It's not just your cell phones and just this and just that. Every time a volcano erupts or anything happens, there's a bunch of this stuff released, And frankly, we're in a differential. There's more of it coming from raw space than can get through the earth and push you from behind or from below. And so you're just falling in the differential. If I made it rain, there's more rain going this way than there is rain going that way. And you obviously go where the stream goes. It's just like a stream. Your boat's on the side of the stream. You could say it has potential energy. It really doesn't have anything. But when you put it in a stream, it's going to go because it's going to be pushed. It's not going to be pulled downstream. It's going to be pushed downstream. And that's all you're being. When you're free to move in gravity, you're not on the shore anymore. You're not tied to the shore anymore. You're not connected to the shore anymore. The gravity will slide you down.
The heck is it indeed? And we've got some answers, but not all the answers.
Yeah, you have you have made no improvement on the theory in 400 years. So Galileo, Descartes, and Newton gave you pretty good stuff, and you've done zero with it because you invented this silly R² nonsense, this kinetic energy nonsense. You think 4 times the distance in gravity is 4 times the energy, and it's not. You're only going twice as fast. You're only in the gravity 2 units of time. There's nowhere to derive your 4 units of energy from. So it's all absolute nonsense. You've done no good science on the subject of gravity in 372 years.
As you will discover.
Yeah, so we're going to talk about the nature of that mystery. And I want to start with a challenge that I gave you a bit earlier, which I've been working on too, which is how would you describe gravity to an alien from another universe?
Rain. How would I describe it to a 6-year-old? I would describe it as a visual that just shows there's force in the universe, and the fact is the only time you move is when there's a differential in 2 forces. When there's more wind blowing this way than there's wind blowing that way, you go the way the wind that wins. Okay, that's simple. And that's all gravity is. The Earth is burning hot inside because it's captured a bunch of energy that never got to you. Simple answer. The energy should have gotten to you, but it's busy turning rock into liquid. So it doesn't get to you, and that's what you're falling in, is that differential. It's that dirt simple. And you've made such a colossal mess out of it.
That had never experienced gravity.
Mm-hmm. Okay, let me ask some questions about this alien. Does the alien have a physical body?
Yes. And I think, by the way, these questions are very important. They kind of tease out what gravity is.
So, I mean, inventing an alien that's never experienced gravity is just too stupid on its face, because how the frig could it exist in the universe when an electron has, technically, is creating gravity by moving? Certainly atoms, you would say. You would start calling these material objects gravitational. Now, it's actually a charge interaction that's creating the differential in the force, that's making the electrons and protons capable of absorbing the force, is the fact that there is a distinction between force and matter. And obviously the aliens would have to be aware of that. There's nowhere in the universe you can go where you can escape gravitational fields. They're inescapable.
What do you even need to know to experience and understand it?
Yeah.
So, let's say that the alien has a physical body. It has a concept of time very similar to ours. It lives.
Ding, 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 ding. It's a kind of the gay, happy version of Deliverance.
In a world where seconds are pretty fast and years are pretty long, it understands motion. Okay, it understands.
So you can't understand motion and then say you don't understand gravity, because obviously it's one of the most obvious causes of motion you can interact with. It's everywhere. You can't go anywhere in space without there being a gravitational differential, because there's a star closer to you over there than there is over there, and so there's a little tiny bit more gravity going that way. You just never can escape it. You could sit there and say, I'm in between the moon and the Earth. Well, that's not going to do you much good, because as you move in those orbits, the fact is it's going to change what asteroids are nearby, and it's going to change where that position is. So you can never be in any perfectly ungravitational location.
and position and acceleration.
Does it have 3 dimensions?
Yes, it lives in 3 spatial dimensions. It also lives in 1 temporal dimension. But for some reason...
Temporal dimension, whatever that is. The special little time dimension, when it's not a dimension, because frankly there's a frickin' rule about why you have 3 dimensions. It's because there are 3 vectors that have right angles to each other. And you're just cheating again by pretending I'll use the same word for some other wacky thing. The time only exists, right? This is another thing you could explain to an alien, pretty simple, is because the fastest thing in the universe isn't moving instantaneous speed. Or you could almost argue the slowest thing in the universe isn't moving instantaneous speed. So obviously there's this concept of velocity, and it means something going slower than instantaneous. And if something's going slower than instantaneous, then you have time, whether you like it or not.
Its universe has no gravity.
Okay.
And so it needs you to explain what it is.
Oh, whatever. I mean, too ridiculous. It doesn't have gravity. Okay, so, and again, so the concept would just be as simple as you just throw something in a stream of water and just point out that the stream's moving more that way than it is moving that way, so you're going to go the way the stream's going. You're going to get pushed in that direction. And that's what gravity is. I guess they're going to do the bent geodesic nonsense.
Okay, well then I think that the simplest way to think of it is that in our universe, objects are attracted to each other. And if you...
So they're not attracted to each other, they're pushed into each other because every object is absorbing energy. So it's excreting less than it's actually going into it at this exact moment in time, because it's wasting a bunch of energy restoking the heat, putting new heat in. It has to keep putting the heat in to the furnace, and the furnace is kind of slowing down the process of just throwing the coal and have it going into the atmosphere. It's slowing down the process. And so less force is coming out of the earth than force going into the earth at this exact moment. Because you've slowed the force down by obliging it to move electrons and protons. Such a simple answer. And all these people go for this silly religious answer. They just invent this silly wooey nonsense.
Without any interfering from outside, if you just have 2 objects near each other, they will come together. That's it. I mean, that's it.
They will be pushed together by a force. So again, it's not that complicated. There's a differential. More going one way than going the other way, you go the way that the more is going. If there's fish, you're in a fish tank, and more fish bump into you this way than bump into you that way, you move in the direction the more fish pushed you. The more mass, the more momentum of fish, let's say. Total mass and velocity. Whatever the total mass and velocity that's hitting you, if you're in a differential, you're going to move.
Really?
And at this point, the alien goes, "What? That is so odd."
Right.
And what do you mean by an object?
Anything with mass. Anything with mass. Because I think that we sort of imagine...
Oh, brother. So yes, obviously everything that's a thing, there's no concept of a thing being a thing that is a nothing. You have to be a something to be a thing that we're going to identify. You can't be a nothing and be identifiable. So, duh. Meaning the force also has mass. That's why it conveys momentum. Photons convey momentum. They exchange it. They give it. Let's not even say exchange, because they actually do the pushing. They're the Sisyphus. The electrons and protons are the boulders. The force bits are the Sisyphuses doing the pushing. How many pushers on one side, that decides which way you go.
Imagine gravity as though it's like the Earth is pulling us down.
No, it's not doing that. So it's just wrong. If you had a 50-50 chance of getting it right, I don't know why you went with the pull thing. What the frig is a pull? I mean, it's so easy for me to do a push. A push is just, I could just throw something. If I could throw something at the camera, I'm trying to find something of the appropriate weight. Okay, this little thing. How much damage could that do? I could throw something, I cause a collision, I make you move. I can't I can't pull on you. Okay, not possible.
But the thing is that we're also pulling the Earth up, right? And if you get...
So that's the silly part. No, you're not pulling anything up as you're connected to the Earth, actually. So you can't do much. In terms of applying a force that could do anything but cause you to sink into the Earth. But it's just the wrong way to think about it. I mean, obviously, yes, you have a tiny gravitational field. The Earth has a gigantic gravitational field. It's absorbing millions and millions and millions of joules of heat. So it's obviously absorbing a ton of energy to keep itself molten. A ton of energy has to keep going in there to keep melting it. A tiny little thing, tiny little differential you're creating. So it's you're not interacting with the Earth to create your gravity. The Earth doesn't have to exist for you to have gravity. You don't have to exist for the Earth to have gravity. It's not an exchange of some kind. It's happening to every material substance, that every time electrons and protons are moved, they absorb a force to do it. There's less Sisyphuses available. If the Sisyphuses are all busy pushing boulders back and forth, you can understand that they can't be going somewhere else because they're busy pushing a boulder back and forth.
You get much smaller objects than planets and you put them in space. They're pulling each other and will come...
The only useful part of this conversation, talking about size, is to point out that an atom is affected exactly as the big giant objects. So they fall at the same rate, they move at the same rate, they have the same orbital speed, because that's all the force really is a subnuclear type force. It's moving electrons and protons. It's not even moving atoms. It's moving electrons and protons, the smallest things, smallest matter bits available in the universe. That's what it's moving. It's not moving anything else. It's not affecting anything else directly. That's the only universe that is the universe where the electrons and protons are floating around in empty space and getting bombarded by photonic style force bits.
Together.
That's right. Yeah, I once calculated that two baseballs placed in intergalactic space, a meter apart, would very slowly collapse in towards each other.
Yes, and so what's the calculation? 400 years? Yeah.
Until they touched. It would take 3 days for that to happen, but it would...
Okay, well, that's a good... 3 days isn't too long. Why didn't the space shuttle people do that experiment? Shit, it's only 3 days. They could have done that experiment.
Would be because of their gravitational attraction to each other. We are gravitationally attracted to each other right now. It cannot overcome the air it would have to push out of the way, the friction between our butts and the seats.
Well, that's the only thing really stopping it. So if you got rid of the friction, the air resistance is nothing at those low velocities. So you can't use air resistance as an excuse for why you don't end up smashing into each other, because it's negligible. So the only thing that's really stopping you is the friction. Get rid of the friction, then you should slide together in 3 days or something like that. I mean, you're bigger, so it should be easier for you to crash into each other than the smaller baseballs. You fall at the same rate, so yeah, it can't take it. If it's 3 days, then it's 3 days. 3 days for everything.
But yet we are attracted. In fact, when you're born, right? You've got some...
Well, it's 3 days if it was the same gravitational pull. Obviously, the big object has a bigger gravitational pull. So yeah, so if they did that experiment, put 10-pound weights a meter apart, we should be seeing them crash into each other in a matter of hours. Why didn't they do that in space then? Why didn't they do that experiment in space? I'm sure they have some sort of equipment that weighs 10 pounds. And they could stick it out in space for a little while and just see what it does.
Some zodiac constellation that's like, I don't know, it's... How does astrology work?
something Pisces.
Right. Okay. You're a...
Why bother with all that? I'm just stuck. Just thinking about this. I'm saying if he's right, that's 3 days for baseballs. I mean, why hasn't this experiment? Why didn't they do it? They were on the moon for like 5 days or something. Why wouldn't they do the experiment? Yeah. Well, there's gravity. That's the problem there, the moon. So, yeah. But, yeah, on the space shuttle, they're doing the free fall thing, so they can just go out into the bay and they put two objects. They're not going to go anywhere. Theoretically, they got nowhere to go. They're going exactly the same velocity, being bent by the thing the same amount. They're not going to go anywhere. So you should be able to just watch them crash into each other.
You're a Pisces if you're born in a particular time of the year. But yet, the gravitational influence of Pisces on you is less than the gravitational influence of the doctor who delivered you on you.
Because otherwise, birth ain't working.
That's why, yeah, people are like, oh, so you're an Aquarius. And I'm like, no, I'm a Schnitt cookie. Because
yeah, well, I wouldn't have called you a Schnitt cookie. I might have called you a fuck wobble or a douche knuckle. But, yeah, not a schnitzel.
Dr. Schnitt Cookie was there influencing me
to catch
at
you.
a physical level, yeah. Not just the catching, not just the physical touch, but the gravitational attraction to his mass.
Right.
It's been with me my whole life.
Yeah, but there's billions and billions and billions and billions and billions and billions and billions of shit nookie fucking galaxies, and then all the stars in those. There's a lot of stuff out there that's just pulling a little tiny bit. And if you add up all those little tiny pulls, it adds up to something. You know. So yeah, what do I do with commercials? I guess I just play them. Yeah, it's tough shit, people.
Friday is company karaoke, 90s pop
I have
theme.
to have the right window
I'm
for
something
that.
of a karaoke cunt.
There we go.
Where is he now? Eh?
Now, I want to be this alien again, and I want to say, all right, so objects with mass enjoy each other's company. They come together.
They do.
What's mass?
Oh, no, now we're getting into trouble. Because, I mean, this very quickly gets into nasty...
Obviously, mass is the something that gets pushed by the Sisyphuses, so you could call it boulderishness. But obviously, it's electrons and protons, so that's the stuff that we measure as having mass. Now, I would argue the photons do too, but their mass is so small and they're moving so fast we can't measure their mass because they're always moving somewhere. But that's their mass in the direction they're moving. They don't have mass going this way and that way. They don't have mass going backwards. They only have mass in the direction they're moving. Whereas regular electrons and protons have mass in any direction. So it doesn't matter which way you hit them. They have mass, and then they'll have momentum if you give them a velocity. So they have mass without velocity, and then they have momentum when you give them a velocity. Not very complicated. Alright, so let's see. Temporal dimension, I've not heard of that. Yeah, I don't know. Temporal is something to do with your brain, right? So what the hell is that? Anyway. Let's see. Anyway, I haven't seen Vsauce channel for years. Is that what this is? This is that Vsauce guy? I thought he was supposed to be smart. I mean, this is just, you know, chucklehead kind of science. You know, whatever. Thought I recognized him somewhere. That just amazes me. Yeah, well, he sure became a nothing. I mean, doing this, you know, I mean, it's got 50,000 viewers, but I mean, it's not exactly taking over the internet. Well, this one's got 255. Well, how to drink lava. I mean, what a silly fucking conversation. Who the fuck would have a conversation about drinking lava? I mean, too ridiculous. Obviously, it's so hot, okay, that as long as you keep it hot, it'll bounce off of everything, you know, because of the vapor effect. So technically, as long as it stays hot, I guess it could go right through you. Technically, I've been creating a bunch of steam, and so you'd have a hell of a lot of gas. But it might do minimal damage if it's a minimal amount.
The quantum physics territory.
It does. And so let me just posit some possible answers.
Go on.
One is that, look, when I say mass, in this context, I just mean the amount of matter something is made of.
Right, and the matter is electrons and protons, and neutrons are just an electron and a proton. So it's just electrons and protons being pushed around. Obviously, electrons and protons are charged, which means they cause dipoles to happen. That is, when an electron and a proton are really close together, it's a dipole. It's a magnet. And then you can make big magnets out of little magnets if they're all pointed in the same direction. And, gee, the physics is really so simple, and they've made such a stinking mess out of it.
Yeah.
Which, in our universe, does a couple of things. It affects how attractive and attracting it is to other object.
Again, pulley, pull, 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 magic, pull, 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 which doesn't have any elemental pull. What's an elemental pull? Like an elemental wave, it doesn't make any sense. You can't have an elemental wave. You can't have an elemental pull. These are not real concepts. They are just let this nonsense rubbish go because it doesn't have anything to do with physics, which is collision. Collision, 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 collision. It's bumping particles. That's all it is. It's stuff banging into stuff and transferring its character, its properties, what it's collected. It's collected some shit. It bangs into something. The shit falls onto the other guy, falls into the other guy's truck. It's like two trucks hit each other, and then one guy's pickup truck throws all the shit it has into the other guy's pickup truck.
But it also affects how hard it is to change the motion of the object. And these...
So again, changing how hard it is to change its motion. Again, motion isn't hard. It's really easy. It's really easy to give a homeless man $5. He doesn't sit there and say, no, don't give me the money. I can't take the money. I'm going to run away. I'm going to avoid it. I have inertia. Inertia. No, none of that happens. If you want something to have energy, you have to give it energy. If it doesn't have any sisyphuses pushing, then it doesn't go anywhere. You have to give it for it to have. Or else it has to take it, okay, by banging into you and forcing the money to fall out of your pocket and fall into his. But some exchange has to take place, and there's no resistance to motion. You just have to give something enough energy to be moved.
Might be different things. Gravitational mass and what we call inertial mass.
Yeah.
Ugh. So I just saw this comment, made me throw up in my mouth. I love Vsauce. Fuck you. You're an idiot. I mean, how could you love? It's all his videos were obtuse mush, and here he's proving it. He's just douchebag all over the fucking place. What the fuck? Give me a link to the, send me an email or something. Show me the fucking video he ever made that was worth watching. Please, show me that video. Pretentious douche. I emailed him years ago. I offered them the money, the whole smear. Didn't get it, and didn't even get a reply from the fucking douche. Ugh. Oh, okay, so you meant you were retarded when you were a kid. Okay, good. Yes, most kids are retarded. Yeah, and so I'm sorry you fell for it. I'm sorry you thought all that wooey crap he talked about was worth listening to. Because it's all wooey, complex, nonsense, mathematical shit instead of anything real. Yeah, well, being also well-read, what does that mean in this circumstance? It doesn't mean anything. All these real well-read people are saying it's 9.8 meters per second squared. Why is the second squared? Well, because it's per second. And so, yeah, you really should be saying I'm going 60 miles an hour per hour because, you're missing out on that extra fun part. I mean, it's just bullshit. I'm sorry you were duped.
An object that's really hard to speed up and push around has a lot.
So again, it's not hard to do. You just have to give it enough. You can't, you could put a tiny bit of gas in a little tiny motor. You have to put a lot of gas in a big motor. I mean, it's just the rules, right? So if it has a whole bunch of electrons and protons, you can't expect to make them just... Well, this is actually what Leibniz thought. Leibniz thought the same force could shoot a pea 50 miles an hour and shoot a 5-ton boulder 50 miles an hour. He actually thought that was somehow possible. That's how dumb the physics is. I mean, obviously, if there's more electrons, you can figure out... Like if it was sandwich bread, oh, there's more people coming for lunch. I guess I have to have more bread or they're not going to have anything to eat. I mean, duh. Yeah, you need more fuel if you want to fuel 100 people than if you want to feed 100 people, it's going to take more bread than feeding one person. Well, that's just a duh.
Lot of inertia.
Like
It also has
resistance
a lot
to
of mass.
motion,
Resistance to motion.
So there's no resistance to motion. It's too bad Newton used that terminology because it just doesn't exist. Nothing resists being moved. except in the circumstance like static friction, where something's sitting on the surface long enough that it almost bonds to it and glues itself to it. And so you have to break that static friction, but that's the only circumstance in which there's any legitimate amount of resistance to move. Obviously, every time there's friction, movement's going to be expensive because you're going to lose a bunch of your work. A bunch of the sandwich bread is going to get ground up in the friction wheels. So obviously in pure space, though, you blow on something, it'll probably move. The trick is if you gave it so little energy that all the electrons can't move at all. I mean, you can't push them because you gave it too little energy. Then all you're going to do is get the energy back. It's going to bounce back off one side and come back the other way and push you away instead.
Change.
Yes, absolutely.
And gravitational attraction, they're both related to mass. They correlate with it. But
so that doesn't mean anything. They correlate, they're related to this attraction thing. And again, the retraction is an illusion. They're being shoved into each other. They're not attracted. They're being pushed. All right, take a little break and have some smoke. I probably could play video while I'm doing that, but I don't want to miss out on another crappy sentence worth of nonsense. I mean, every sentence is bullshit. Look, it's just so obvious that they've taken a well-modeled understanding where, like Descartes just pointing out that the energy is always in the universe. It's just changing who's got it. I mean, it's such a simple concept, and if physics would have stuck with that, they wouldn't have any of this. All this wooey crap wouldn't exist, because that's thermodynamics, that's motion, that's energy, that's everything. It's telling you the whole story right there. You're done. There's just this idea of the essential mover and the movables. So you have an essential mover, the force, the little bits moving the speed of light, and you have the force bits, the matter bits, which are just electrons and protons. If the electrons and protons are doing a lot of moving, well, then there has to be less force out there. And if they're doing very little movement, then there has to be more force flying. It's just not that complicated. It's not anything like the perversion they've turned it into.
Is there still debate around whether they're the same thing?
One thing I would say that those ideas of inertial mass, that objects resist changes in motion, I like to think that's sort of how I live my life, Like when you're in bed in the morning, it's like I'm happy staying in bed. And then I don't like changing. So don't like getting up. Once I'm working, right, I don't like stopping working. Once I'm awake, I don't like going to bed. It's like I don't like the change.
That's right. And to change what you're doing, something kind of forceful is required.
Oh, well, no, it's the whole point, though. That's the whole statement. You're just exchanging it. Something is tired of working, and it's saying, "Here, you work." It's always an exchange of condition. Things bump into each other. They have a condition they're in, and they share their condition based on how long they're in contact. If they're in contact a long time, then their condition becomes equalized, and they end up being the same in the same condition. It's that simple. But yeah, if one is 10 and one is 0, well, then they're both going to end up 5.
That's the vocabulary that physics uses. If something's motion changes, a force has acted on it.
Look, Newton was just a lazy guy.
So I want to take a step back and say we've been talking a lot about very fundamental things in this really abstract way to just explain.
So there's no abstract, there's no anything. You haven't talked in any terms that actually make any sense because you keep saying the word pull that can't be reduced to any kind of rational mechanism. There's no such thing as an elemental pull. It can't exist as an elemental function. It's magic. It's Henry Potter crapola. And it's the foundation of your nonsense physics.
That things fall down. Because here on Earth, they're attracted to the Earth.
So again, they're not attracted. They're being pushed into the earth by an active stream of photonic energy, then the stream is stronger going down than it is coming back up out of the earth, and therefore you fall into the difference. That model perfectly illustrates the inverse square law. It does all of the mathematical physics. It's exactly the way Leonard Susskind teaches relativity, is to create that liquid, that stream, and just basically saying, yes, there's a convergence into the center of the earth. The water, there's a drain there, and all the water's going to the drain, and there's an endless supply of new water. I mean, it's just ridiculous. They use mock gravity to explain their abstract gravity, and it's the mock gravity that's the actual gravity, and they're just mocking gravity with their silly relativity bent geodesic crap.
And you were talking about how it's not just the Earth pulling things in. Things pull the Earth as well, but the Earth is so much bigger than everything else we work with. That equal attraction they have affects...
And you could say the words, it's much hotter. The Earth is insanely hot. Okay. Do you have any lava inside of you? Oh, no, you don't. Okay. So clearly the Earth is converting, okay, an awful lot of something into an awful lot of heat. And the something is the force that would have kept you floating. But it didn't show up to keep you floating.
Other stuff, like a pen, a lot more than it does the Earth. But I once calculated that if you dropped a pen from 6 feet up...
That's his big fun thing to do, is to calculate. So everything drops the same speed, blah, 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 pen from 6 feet. I should be able to calculate that's going to be a second, 1 second. No, 6 feet is only a meter and a half. So that's like, whatever, 0.2 of a second or something.
It actually pulls the Earth up towards it 9 trillionths the width of a proton.
Right, 9 trillionths the width of the proton. Actually, they've done this experiment with much heavier objects, and it's actually true, because when you're falling, you're absorbing, right, the energy of the force. It's now inside the object, okay? It's not, didn't get where it was going. And so actually, when you get really close to the Earth, when an object gets really close that has some mass, the Earth actually lifts up little pieces. It was confetti. Little pieces of confetti would rise to hit the object before it hit the Earth. So the fact is that it is a kind of opposite gravitational effect, because you're absorbed for that tiny amount of area. You've absorbed an equal amount of force, and now it's back to being even Steven. All right, there's a couple more comments. Let's see what we got. Their model of reality is too wacky, especially the pull force. Yes, I'm just saying, every time a physicist says random, or they say spontaneous, or they say pull, yeah, they're not talking reasonable. Well, you can't call the woman dumb yet. She's just, they're doing Abbott and Costello. They're just, so we don't know who Costello is yet. Who's dumber? I mean, obviously she's playing the, ignorant tart, and I don't think she's actually ignorant. So I think she knows plenty. And they're just playing, like, let's pretend we're role-playing in these positions. And so Arkansas Man is pretending to be Mr. Answers. But he still hasn't given us his alien answer. How do you explain to the alien that never experienced gravity? A differential and a force. That things move downstream. Yeah. How do you explain things moving downstream? I mean, that's all gravity is. It's a stream. You can hold something. It's just like holding the boat against the current. You can feel yourself holding it against the current, and then you can just let it go into the current.
Oh! Which is by my calculation, small.
It's very small. So the pen falls the remainder of that distance, which is still pretty much 6 feet.
But they are coming to meet each other.
But they're coming to meet each other somewhere in between.
Yeah.
Well, obviously they're not meeting each other on equal terms. One of them has acquired a momentum, and the momentum is going to be an impact, and it's going to win the impact because it's going to technically have a lot more momentum, okay, than the Earth movement towards the pen. And so the momentum is going to cause damage to the Earth. It's not going to be the other way around.
Yeah.
It just happens to be a much longer trip for the pen. And there you've got both of those senses of mass happening together, the gravitational attraction, but then also that.
So again, he says the word, every time he says the word attraction, I have to react. But I mean, it's just wrong. It's not attraction. They're being pushed into each other. They're not voluntarily engaging in their intercourse.
Force moves each object with very different accelerations.
I mean, that pen, though, is particularly light. If you take an object that is heavier, denser, I mean, heavier, actually, there's sort of an implication of gravity in that statement itself, right? But if you take something that has more matter,
yes, then it will be only the distance of 4 protons. So yeah, you're still stuck. You make the pen out of titanium, it's gonna cause more of a reaction from the surface when it gets close, but it's still a tiny reaction. It's a tiny amount of gravity.
the amount that the Earth would move would change too.
That's right. That's right. And so when people say a feather and a hammer dropped in a vacuum, so there's no air to move out of the way.
Right, so one's a big giant sail collecting lots and lots of momentum, lots of air, lots of wind is being collected by the hammer because it's got a gigantic sail. The sail is the number of electrons and protons. The feather has 1/1,000,000th the number of electrons and protons. So obviously when the hammer hits the ground, it's got millions of Sisyphuses pushing boulders. It's the Sisyphus power. How many Sisyphuses does it collect? How many elements of force does it collect? Well, the collector is the electrons and protons, and every one is collecting equally. So it's collecting a ton of force. Okay, and so when it hits the ground, it's going to make a mess because it's collected the stream's power. It now has it. It has what the stream, it's like you put the boat in the stream loses a little bit of power to give you the power. It exchanges its force by giving you its force. And so now it has less total force. The water moves a little tiny bit slower, but now your atoms are moving with the missing amount of energy. The missing energy is now in your boat. You've taken energy out of the field, put it in the hammer, and now the hammer, when it hits the ground, is going to return the energy that it took from the stream.
They will fall at the same rate. They'll hit the ground at the same time.
I tell you what, why don't we just clear up?
And they won't hit the ground with the same impact, the same result. Won't be anywhere near the same result.
The question of what is gravity, according to what different people thought are different.
I mean, clearly gravity is energy. I mean, you can't get away from the fact that this is a real pushing force. And you're just saying, which way am I collecting push? And the way you collect it, the push is by being pushed. Something has to give you the velocity. You have to take it from something.
Times.
Yeah.
Because everything you're describing so far is essentially like a Newtonian view of gravity.
Well, that's all there is. Newton was right. He wasn't wrong. He was right.
So Newton has this idea that actually gravity is all about objects accelerating towards each other, right? You know, force is mass times acceleration was one of his laws, and he was saying that we are accelerating towards the Earth, which is the reason why.
Well, yeah, and his essential formula was just a waste because obviously he did connect the two objects and calculate some kind of total force, and there's no such thing as a total force. The only force that matters is the individual force applied, the differential created by the Earth, and then the differential you create. But that's That's all there is. There isn't any way to multiply that. You can only add that.
When you chuck an apple, or any object, your baseball if you like, when you chuck it, it accelerates towards the earth and follows this curved path. And everyone for, many hundreds of years was like, that guy Newton, he's got it made. He's done it for us. That's
right, but that's the catch, right? And then when they talk about what happens when the ball hits the ground, the fact is that it's going to have, it's not going to have the full energy this way and the full energy that way. It's going to have this hypotenuse energy. So it's going to have energy in a vector that isn't going to be perpendicular to the ground, or linear pushing the surface, but it's definitely, you've got two sources. You've got the original velocity plus the new source of energy in going down, so you definitely have more energy than if you didn't fall.
It's perfect. But there were still some lingering questions, some little things that didn't quite make sense. So, for instance, how is this force sort of acting? Like, let's say you took the sun and
It's acting exactly like light from the sun. So again, it's just so funny they ask the question, how is it acting? Well, it's doing exactly what a light bulb does, exactly what the sun does, except in reverse. So it's the same exact rules. It's a force. Convergence is just the same thing as a divergence. So a light bulb is diverging photons and the Earth is converging. Same exact formulas, same exact mechanics, everything. And it's a speed of light force to boot. So it's going the same speed as gravity. So if you just thought of photons as something converging into the earth and pushing you into the earth, you could understand that, okay, yeah, there's lots of light out here and it's very dark coming from the ground. And it's exactly the same mechanism. You're just absorbing the light, so to speak.
You had like a magic wand that made the sun disappear instantaneously. It would take 8-9 minutes for the light to hit us. But according to Newton's version of gravity...
No, it really isn't Newton's version of gravity, because he didn't draw any conclusions about that, and they discovered the speed of light while Newton was still alive. They were, figuring that part out. So Newton wasn't out of that game. It's just that he was busy doing the treasury thing. He had a real job, all of that kind of crap. So he didn't rewrite. He didn't fix the what could be implied from what he said. But I'm just saying he had no reason when he started to recognize that the force had a limited speed. He had no way to know. And then by the time he's 60 or whatever, well, they've already done a few of these experiments that kind of just point out that light takes time, and they were starting to get numbers that were realistic. So obviously Newton wasn't completely ignorant of that concept, and it wasn't like he was pushing the fact that photons are instantaneous, because he wasn't. So that's just cheating Newton, because the fact is, it's just like Galileo didn't have a second. He knew what time was, he just didn't have a unit.
We would immediately stop accelerating towards the sun, which means that the Earth should immediately spin off into the blackness of space. But that's sort of...
So again, that's not... I don't think Newton... If you interviewed Newton, Newton wouldn't say that. He would agree that the force is moving at a limited speed, and therefore it will take time before you'll see the difference. Like I said, he did all of these observations. He obviously... this was happening while he was still alive, while they were discovering these other planets, and the moons weren't the right orbital speed. So all of this was already being figured out while Newton was alive. It's just that Newton wasn't a player anymore, because, he had a real job.
It doesn't really make any sense, right? Because isn't it that nothing can travel faster than the speed of light? So how can it be that we would feel the loss of the gravitational pull of the sun before the light switched out?
Right. Yeah, and so we know for a fact today that gravity travels.
So they're going to say they know because of the stupid LIGO experiment, and that's not how they know. Okay, there's lots of other ways you can deduce, again, just from observational data about how things are moving, and recognizing that if you give gravity a speed, the calculations get more and more accurate. So if you give light a speed, your calculations get more accurate. And then if you give gravity at the same speed, they get even more accurate. So the fact is the predictive power increases by giving gravity a speed of light influence.
How fast?
Speed of light.
Speed of light, no faster.
Well, it's the universal speed limit.
Yeah.
So it's not a universal speed limit. It's just the fastest that something's moving. And if it's just pushers and rocks, you can understand the rocks can't go faster than the fucking pushers. Excuse my vulgarity. They can't go faster than the things pushing.
Certainly, it's not instantaneous.
Absolutely. Which means that if the sun suddenly vanished, we wouldn't know about it at all.
But was that a problem for Newton?
Newton, no. But as the time went on, people were like, there's something a bit fishy going on. There's something a bit weird. I'm not sure I like it.
So again, I'm just saying that, yeah, obviously Newton was done being a scientist when he was, whatever, 45 or something, and he became, all kinds of other things, okay? So he really wasn't, he wrote optics, and that was the end, right? So there wasn't any, in the second half of his life, and it's amazing they got all the good stuff done in the first half of his life.
The other one that was a bit weird that people just couldn't quite work out is Mercury's orbit. The thing about Mercury, closest planet to the sun, it has this ellipse.
So they always got to bring up this crap. So they just ruin the whole subject of gravity just because they're going to talk about one little tiny defect. And it's a defect in a circumstance where you could plainly understand that Mercury is in a completely different environment than every other planet, right? It's the closest one to the sun, and it's extremely close to the sun. So, it just should be illustrated over and over again that this isn't even a challenging idea, okay? This is the sun, Mercury's there, okay? The Earth and Venus are out here, like those kind of distances from each other. So you can't compare what's happening here to what's happening here because those two environments are completely different. So all you have to do is have a tiny precession inside the sun, just a little bit of a wobble in its core. So if its core wasn't perfectly round and had a lump on it, and had a little bit of a tumor or something, or if it was made out of two objects that were rotating, two harder clumps, you can understand that would be creating a change in the gravitational field because the density of the sun is not perfectly consistent, it's perfectly rotating, and so that would cause Mercury to gain its precessional problem of, wobbling in its orbit. A simple answer does satisfy the conundrum. They don't want the simple answer. Simple truth. They don't want it. Okay? The simple answer answers the question. I just make the argument the core of the sun is precessing. You can only detect the precession when you're really close. We can't put a satellite really close. We can only do a flyby. We can't hang around, in Mercury's orbit because the satellite will burn into a crisp. So, this theory does work. And there is an argument that Einstein's insanely convoluted math, which nobody ever does, his field equations, which aren't really equations, they're just a description of a bunch of other equations, that all they're really doing is processing the sun. That's exactly how he makes Mercury fit. See, the precession, the influence, the wobble is so small, but it'll affect Mercury, the small planet very close, and it's too far away to affect Venus and the Earth and Mars because they're too far away to be influenced by the tiny wobble. A perfectly reasonable answer that they won't even consider, okay, let alone investigate thoroughly.
Elliptical orbit. But that elliptical orbit is itself spinning around. It's affected by the other planets. So it doesn't trace out the same ellipse every single time it orbits the sun. That ellipse is moving around.
Yeah.
It's doing something different than the other. All the other planets are doing regular. Yes, they're influencing each other, but all the influences are within the understandable limits. Mercury isn't. So it's really just about its proximity to the sun. not its distance from other planets. It's about how close it is to the sun, not how far away it is from Venus. Jeez, people are just so annoying. All right, well, this Hernandez guy probably has to go. Stupid ass name. V says has 5 kids, despite saying one of his videos that life has an extreme amount of suffering. Well, obviously, yeah, he's just a cruel, glib fucktard, like most people. I don't believe Newton would have believed gravity was a pull force. Yeah, I don't think he would have either. Well, look, the point is he signed Fadio's paper, and Fadio's paper was the original Lesage gravity. So there were a couple of years, and Fadio and Newton were very good friends. I mean, they were good to each other. Fadio was a great defender of Newton when it came to the Leibniz-Newton argument over calculus. So the guy who invented particle gravity, or the first one to discover it, the first one to say that makes sense, was there in this conversation, and yet they just ignore that piece of history is just erased from anybody's knowledge. But the fact is that Newton was looking for those kind of answers. But, you know, there's lots of these little things where somebody says, well, what about drag? You know, and if you don't think about drag pretty hard, you're not going to figure out that it doesn't matter. There is no drag. But anyway, he just made 2 this year, FYI. 2 kids? Ew. Ew. Mr. Arkansas? I mean, you know, I whatever people want to do, but I mean, it's just, to me, if you got some obvious, like, premature balding and, you know, micro penis or something, don't bother having kids, because you're really not going to do them a favor. You know, eek. Let's see, that's what I heard, but it might be wrong. Well, then why are you bringing it up? I think he made a video on antinatalism. Well, that would be funny. NVM, he didn't make a video on antinatalism, it was vehement, or whatever. Vehement is stupid. Voluntary human extermination movement toilet. I don't know what the T is for. But anyway, it's just too stupid. Get rid of the smart things and leave all the dumb things to kill each other. Oh, what a great idea. Anyway, you're off the subject as usual. Fuck you, damn. Okay, anyway. Get a new name.
The perihelion of Mercury's orbit.
Okay.
Which sort of makes sense, right? Helion meaning sun.
Yeah, so she's just playing dumb because she knows this fancy perihelion word. So she obviously knows about all this parabola orbits and all this blah, 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 blah. And she's just playing dumb.
And everyone was cool with that. Everyone was absolutely fine with that. That they knew that, you know, the orbit was going to change because of where different planets were. But when...
So again, it wasn't because of where different planets were, and that was the problem. There was no explanation for why Mercury isn't behaving perfectly. So all the other planets were within, you know, 2 feet of where they're supposed to be. So they're making predictions where they're predicting within like 2 feet. So they're saying, I can predict where the Earth will be 2 years from now within 2 feet. You know, and when it came to Mercury, they were like 10 feet off.
And they ran the calculations according to Newton's version of gravity, that it's essentially just objects accelerating towards...
No, so this is, again, bullshit. It's not Newton's concept of gravity. Newton didn't think the sun was precessing. Obviously, it was a point in space. It never changed. So, yes, Newtonian calculations were... You didn't assume the sun's core was moving in a circle or in any kind of motion, that it wasn't precessing itself. You assumed it was in one dead spot and it had a velocity vector through space, but it was always in one location in that 2-dimensional frame of the orbiting, the stuff orbiting the sun. So that in that plane, okay, you had a stable environment and the sun was in a fixed location. So that's the reason why they didn't get it right, is because if they made the sun move a little tiny bit, then they could make Mercury move a little tiny bit, and all the rest of their planets wouldn't be bothered at all.
Each other. Something was off, right? It was like the number of arc seconds of Mercury's orbit just didn't totally make sense. And for a long time, you know, the telescopes weren't that accurate. People were like, maybe we've just made a miscalculation. It's sort of a bit... I don't know.
And this was for a long time.
Like hundreds of years. And then when Einstein came along and he was like, I think there's something else going on here. Einstein.
No, it's not what happened. He didn't think about Mercury at all. That had nothing to do with it. That came much later when he was obliged to prove his theory. And that's when he wrote all these silly frickin' nonsense equations. So again, get the history right. It wasn't Mercury that made him think, oh, there needs to be a better answer. He was just a daydreamer who was sitting there pretending I could make some kind of equivalence statement about relativity. So it's just his own lost in that bullshit that somehow there's no real motion in the universe and somehow things don't have actual energy. I mean, it was just gooey mush. It was such a gooey theory of mush. But the history is Mercury was not the reason why he invented this crap.
Einstein has this great intuition that it's not just that objects are magically accelerating towards each other, but that space-time itself.
Oh, it's such crap. You know, that somehow the space is disappearing and the space is poofing into existence, and it's just such a pile of shit. You know, it's the space and time warping nonsense. I don't know why people believe this crap. You can't escape the universe. So again, I'll make the simple argument against time dilation is that everywhere in the universe there's all the same number of these photons flying into everything. Okay, it's pretty much chaos everywhere you go. There's a billion or 1,000,000,006 or 1,000,000,007 hitting you per billionth of a second. You're getting, that's how many things, bits of force are flying through you, and you can't change that. Doesn't matter how fast you're going. Yes, you can crash into more going forward, but the same number you crash into extra going this way is the same number that don't crash into you coming from behind. So in total you get hit by the same amount of force every millisecond you're in the universe, and you can never turn that camera off. That video camera is always running at the same speed. You're getting the same number of little bits of shit are interacting with your electrons and protons, and you can't escape it. You're at equilibrium with the universe. You're reflecting the damn universe, okay? You're not absorbing it and getting hotter and hotter and hotter and hotter. It ain't happening. And that destroys relativity, because frankly, that's the real clock. The real clock is how, here's a lump of space. How much force is going through that lump of space? That's the real clock.
Has this curvature to it. So the sun, for instance, this giant gravitational force is
the big giant thing on fire. Yeah. Oh, what does that look like? Well, it looks like energy to me. Where did it get the energy? Oh, it's poofiness. It's blah 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 blah. Oh, nuclear fusion. You know, it makes an atom and then destroys the atom and then makes the atom and just. Well, it's just. It's just such a pile of crap, right? How is this thing on fire? Well, it has to be on fire because it's absorbed energy. And how does it stay on fire? Well, something has to keep shoving energy into it. Okay, and some idea that, well, it made the helium, then it blew up and shot the helium into space, and then the helium went back into the fucking, the hydrogen back into the sun again, and now you're going to make it into the bigger atoms, and making bigger atoms is somehow creates energy when it doesn't. Breaking big atoms makes energy. But anyway, the sun is hot because of gravity, just as the earth is molten because of gravity. That's how you create the differential, is moving electrons and protons. When you move electrons and protons, they get hot. So anytime you see heat, you know you're exchanging energy.
Truly bending and warping space-time between us and...
So nothing bends, and that causes some things to move. I mean, it's just, I hate this crap. Why do people eat this crap? This is Holy Ghost science. I mean, there's no good reason to believe in a Holy Ghost. What the fuck are you talking about? What's a ghost? What's the difference between a ghost and an angel? You know, what's the difference? Why did you call it the Holy Angel? Why do you have to call it the Holy Ghost? Ugh, it's just so fucking stupid. Ugh. bent nothing. The bent nothing is controlling the universe. No, it isn't. Heat is controlling the universe. Thermodynamics. Let's see. So let's see, they erased something. That's okay. I used to watch him, but actually quite beautiful. I actually watched him too, but I'm actually quite beautiful. I don't know what that means. Alright, anyway. True, we would never know, so I don't know what that's a reaction to. Let's see. I'm probably fat because my parents put me on antidepressants and mind-numbing substances as a kid, which destroyed me forever and gave me... Well, look, there's no... you can make that argument of getting fat can be a tragedy, that you got fat. But the fact that you didn't get unfat, that's on you, sort of. I mean, the principle of eating a little bit less food than you need every day, that's not exactly prison. I mean, it's not that terrible, awful a thing that, I have to eat a little bit less than I want to eat. And once you understand it's all about metabolism, you can eat popcorn or peanuts or something. They'll go right through you. You won't digest any of it. And so you'll still be able to eat, but you just have to, do some sloppy pooing. But anyway, I'm not going to sit here to judge, okay? It's not my job to do that. I'm just saying that, making excuses is just sort of bullshit. It's not that hard to figure out, I don't think. I mean, I never got fat because if I started getting fat, it bugged me. It has to bug you. Let's see, she was responding to one of my comments you didn't read at the top. Yes, well, whatever, blah, blah, blah. You're responding to each other in, vaporous, whatever, bent space. Yeah, I can't follow all of your bent space conversations. I don't want to imagine how they could even model what they say to make sense. Photons waving, for example. Yes, though, this whole bullshit. How does it know how to do that? A photon, the dumbest, stupidest, simplest thing in the universe, is somehow doing all of this crap. Yeah, bullshit it is.
And so, if you got a magical wand and you made the sun disappear immediately, there would be this ripple that was sent out from the...
So there's no ripple, there's no nothing. It's just all of a sudden there was a differential, and eventually you're going to get to a point where the differential will disappear. And now there'll be the same force, and so you won't be falling into the void created by the sun because it's not there anymore. It's not absorbing heat, it's not absorbing energy out of the universe, so now you'll get hit by the light. You'll see the light. So as ironic as that is, the sun is consuming the light, and you get rid of it, you'll see the light, and the force will be equalized.
Absence of that sun. Imagine taking a bowling ball on a rubber sheet and then removing.
So again, it's just wrong. Rubber sheet means you're going to use gravity to model gravity, and that's just cheating. So using the solution, using the key to open the door isn't how you make keys. I mean, it doesn't prove the key. I mean, it's just, you can't cheat. You can't use gravity to explain gravity.
Yeah, that rubber sheet is going to kind of bounce up and down and ripple.
Okay, so no, none of that happens. That's just absolute nonsense. There's absolutely no rippling or anything. If it's gone, it's gone. So if you're going to make some argument that it exploded and then pushed a bunch of force, then you're going to have like the opposite of gravity. You're going to get burned up in the extra force.
As you remove
So instead of moving towards where the sun was, you're going to fly exactly the opposite direction. But they're going to get into this gravitational wave crap, and it's just such a pile of crap. This all based on one person's perverse interpretation that somehow you can convert suns into bent space, that you can take their matter, their electrons and protons, and somehow convert it into bent space. When no, you can't do that. No reason to believe you can do that.
Wait, and that ripple would reach us at the speed of light. Had this great intuition, worked out all the calculations.
So people already knew that long before. They were already speculating about gravity having a speed. So they didn't need Einstein to explain that one. So that's just rewriting history. Wrong. That's not Einstein's contribution. Einstein's silly contribution was to take a serious evolution theory and turn it into a Holy Ghost theory. He ruined physics.
For it. And one of the very first things that he turned his equations to was the perihelion of Mercury's orbit.
So again, he didn't do it. Eddington challenged him. Look, Eddington was a believer. He said it's a very interesting theory. So he's only one of the 4 people on Earth who even read the damn papers. And he said, but, you're not going to convince anybody until you come up with some evidence. So why don't you explain this oddity of Mercury? And if you explain this oddity with your theory, well, that'll be points on your side. And then they did the fake Eddington experiment. Again, Eddington was a huge advocate. And so you have good reason to think that, oh, okay, that's why somebody who says in their journal, I only got 10% of the data quality, 10% of the data quality, and all of a sudden it's a New York Times headline, Einstein proven right, with absolute crap data.
Orbit to see if his new theory came up with a more accurate prediction.
Right, so and he takes 6 months and gets the help of, I don't know which guy, Max Born, one of these guys, to help him contrive these convoluted mathematical equations to solve this what appears to be a simple problem. It's a little bit off. Why is it a little bit off? And so they're not like simple equations. They're convoluted, complex, and the real argument is in all that complexity, all they're really doing is processing the sun. So they're letting the sun move, and because the sun is now moving, Mercury can move.
The Newtons. And he absolutely nailed it.
Nailed it.
Level of precision. I mean, he said that he was happy for days after he looked at those calculations, was like, I've absolutely got it. I found the missing piece of the puzzle.
So 2 things. First, that leap from there's a force acting on things, maybe it's mediated by some particle or whatever, to leap from there to actually maybe gravity is just a change in the shape of space-time.
Mm-hmm.
Oh, again, it's just changing the space-time. What the fuck is that? So again, this was one of Newton's first arguments in his book. Okay, so as much as the world, when you read the history, you don't get the idea that everybody was a relativity believer. Obviously, Newton saw it as a threat. And he emphasized these arguments that there's 3 dimensions of space. Okay, and things are located in positions and they are moved into each other. Okay, so he made this really hard that the relativity is only coincidental, it's only incidental. There is no relativity on an absolute sense. There's only relativity and you're both moving in the same direction. You have the same forces affecting you. And so now you can play ping pong and everything will be fine because you're both already in a condition. You're in the same condition. You have the same disease. You can't hurt each other. Okay, something like that. And that's the only relativity. And so he had the spinning bucket argument that, if I spin a bucket and I can't reverse that. So, relativity implies that you can reverse the 2 circumstances and speculate that the whole universe spun instead. But if I spun the whole universe, Newton knew I wasn't going to make more gravity. I can't make the water go up the side of the bucket by spinning the whole universe because it's not going to make any more gravity. It's not going to make the water go up the side of the bucket. So obviously the water is going up the side of the bucket because there's actual energy in the water being spun. It's not relative motion. It's absolute motion. The water has more energy than any of their shared conditions. Of all the objects, you could have a shared condition. Well, as soon as I spin something, I've added energy to that piece, and it has more energy than any of the other stuff they share. It can't be the other way around, that somehow it's the thing not moving. It has to be the thing moving.
Is really gigantic.
Gigantic.
Because space-time is such a bizarrely abstract thing. It's the can.
It's what? It's Casper the Friendly Ghost. It's a silly, stupid, moronic fable. It's such a made-up pile of crap. It doesn't even have the charm of Homer Simpson. It's not even like Cartman. It doesn't have any charm at all. It's a completely silly idea that somehow the space knows what it's doing and it has all this knowledge and it can do math and it can do... This is just ridiculous shit. It's worse than religion, frankly. Worse.
This that we are on. If we were two-dimensional, this would be easier. We could say, a two-dimensional creature could be painted onto this curtain. And if I crumple the curtain up, they're still stuck on it. And they're going over all of these crinkles, but they don't even know it. I can bring them together and push them apart. If it gets crumpled up or curved, you're just going to follow along that curve. You cannot leave it. And so, yeah, Einstein is like, but what if it's the shape of the canvas that we are on?
Exactly.
Even the shape of time.
So again, these analogies don't work because it's a three-dimensional warp. So you can't use curtains to keep talking about it because it happens in 3 dimensions. It's clearly a convergence of space. You're basically saying the center of the Earth is sucking space and pulling it like a vacuum cleaner. And that somehow you have an endless source of space to keep throwing into space. I mean, it's just a ridiculous theory.
And how quickly time runs for you. If we allow that to change, then Mercury's orbit makes sense.
Exactly right. They're crumpling the curtain. That's a really nice way to do it.
Yeah, I think you need analogies because we're just...
So where's Mercury on your crumpled curtain? Where's the analogy to this bullshit that somehow you altered the amount of activity in the universe, that somehow Mercury is in some frame where it's immune to the actual energy in the universe and somehow doesn't interact with the whole universe like we have to every millisecond, that somehow it escapes having to interact with the whole universe. It can't time dilate, it can't time jump, it can't time skip, can't do any of that. It's just such a bad theory.
Talking about things that are so outside of our normal day-to-day activities.
Totally.
We understand forces.
You don't understand forces. You clearly don't understand them because you think something forcing something to do all of this crap. Where's the force coming from? Where's the pusher that makes it go up and down or wobble or oscillate or do any of that crap? Because there isn't any in your model. The stuff in my video right here, that's force. Force is this stuff, vectors of momentum moving through space. That stuff sticks to electrons and protons and makes them move. That's force. Your mushy, bent mush isn't a force. It really can't all be described as simple as boulders, Sisyphus, pushing. Sisyphus is busy pushing a boulder. He can't get to the grocery store. He can't go, to buy a lottery ticket. Can't go to do anything. He has to push the fucking boulder. So he's not going to get where he would have been because he's busy pushing a hunk of matter.
We understand pushes and pulls.
No, we don't understand pulls at all. There's no such fucking thing. There's no elemental pull. Damn. It's just so annoying that they take no responsibility for use of these words. All right, let's see. I don't want to imagine how they could even model what they say to make sense. Photons waving, for example. You should react to Vsauce's older science videos. They're hilarious. I have reacted. I did do videos. I didn't find any of his videos hilarious. I found them obtuse and almost impossible to argue because they were just full of jargon. Space-time is just wet paper as an explanation. Well, I don't know what that means exactly, but fine. I don't know. Just repeat what Gary says. Forced. Good dog. Whatever that even means. He's some kind of godator. He's a godator. Yeah, fuck you, Godditer. You're probably not going to last long. I wish people better understood and didn't just agree and say, oh, yeah, Gary, you're right. Yeah, yeah. No. But, I mean, there's some evidence that the people do get it. It's just the way they say it's bullshit. They don't say it with any kind of creativity. Yeah. But it really is a bad theory. I just don't know, why people just tried to make it real. And again, the fact that the Eddington experiment was so flawed. I mean, everybody knew it was raining, right before the experiment. Obviously, how could you possibly do an atmospheric experiment when after a rain it's really humid, there's all kinds of water molecules still in the atmosphere, it can create a rainbow. I mean, you don't have any way to see what you're looking at anymore. It's just so bad. I mean, this isn't hard to find the truth, and it just amazes me that none of these intellectual bookworms, and that's all they are, kind of, is just nerdy people. They're just so doopy. I do whatever that's why they dress funny, is because mommy told them how to dress. And they couldn't do it their own way. They couldn't do it with any style. They had to just do what mommy says, and they just do what their professor says, and they just do what they're told. They just recite and regurgitate the same crap over and over, and it has no credibility as an actual explanation. Pull is a stupid idea. It has no elemental mechanism. Again, it's that simple. There's no way to elementally describe a pull.
But to say that space and time themselves push and pull, it's kind of more like you're just in them.
But here's the thing, right? The implications of this idea that space-time is like a crumpled curtain.
Yes, it destroys all energy conservation, destroys all mechanical sense to the universe, destroys all of the simplicity of the actual function, which really is just an exchange of force. That's all objects can do, is exchange their condition. The acquired properties. They've acquired stuff in their life's interaction, and they can share their knowledge, so to speak, their information with other things by colliding with them.
Means that across the surface of the Earth, even, the gravitational effects are slightly different. So I did some calculations.
This is just about mountains and places where there's a high, mineral content. So obviously there's a little bit more gravity where there's denser material. Just indicating this isn't about a bent geodesic. It's about objects that are going to absorb energy. So dense materials absorb energy a lot better than non-dense materials, obviously.
Boulder in Colorado, right? Which of course is like a very high altitude compared to Greenwich in London, where I am. The gravitational effect in Boulder is 9.796 meters per second.
And what is it in Greenwich?
9.812.
Wow.
I've got higher gravitational effect than you.
Yeah. So you are more attracted to the center of Earth than I.
So it just has to do with the density again. So as the Earth spins, it flies out, which means you have the same matter, but it's sort of less dense. So your gravity is less because you're essentially further away, from the material. So it's absorbing less of the energy because it's further away from the source at the inverse square law. So it just really is pushing you further out from the center of the Earth, causing the effect. But what's the point of that? So what? Yeah, I mean, that's... Again, you don't need bent space for that. You don't need a model of bent space for that to be understandable. That if you change the shape of the object, you change local gravity. So if we could make a cigar-shaped moon, the fact is it would have greater gravity at the two ends than it would have anywhere along the middle. But we have to make an object big enough to detect those differences. Obviously, we can't detect the differences with a banana. We have to find something much, much bigger to be able to detect those differences. And I think they did do that when they went to one of these asteroids. They found that from different angles it has a different gravitational pull.
I am in Boulder.
Yep.
Because I'm further away.
Yep.
And the inverse square law says
Exactly.
that
Further away,
gravitational
drops
effect
away.
diminishes.
Except that what that means, given Einstein's version of gravity, is that the way that time changes in Boulder is different to the way that time changes in Greenwich.
So again, time doesn't get changed. All you can do is break clocks. So again, this is just more bullshit. You're putting clocks in different environments and then saying the clock doesn't work the same. Duh. So every clock ever made is vulnerable to being broken in its capacity to reliably, consistently record how many electrons and protons are hitting it. But if we could make an actual clock that just measured how many electrons and protons were hitting it, then that clock would be indestructible. All right, it's a corporation and kids tend to watch it. I don't know what that means. Okay, I like unique and correct predictions though, whatever that even means. What does that mean? It's working exactly like a light bulb. You're saying you can't, I need an accurate prediction. Well, that's exactly an accurate model, motherfucker. So you're just playing games. Like I said, you're not going to last too long. Not really. What are you talking to? Who are you talking to? What's a not really mean? I understand Dressano after watching a good amount of his videos. It's hard not to agree when something is rational unless someone can point out otherwise. Yeah, no one comes even close to pointing out otherwise. There's nothing to point out otherwise. I mean, the fact that the Eddington experiment was a pile of shit, and the absolute fact that it doesn't make any goddamn sense to call your people science supporters or science give-a-dammers or truth seekers when you haven't even asked the question, why the fuck haven't they redone the experiment from space? It takes 5 fucking minutes of satellite time. You have 400 times better seeing, and you don't need a fucking eclipse. I mean, why the fuck wouldn't you do the experiment from space? Any dopey satellite with a decent camera could do the experiment better than Eddington. They would have better technology than Eddington had. And they haven't even tried the fucking experiment? That's what we're supposed to believe? They haven't even tried? How can anybody defend that and say they're science interested? They love science. They like science. They can't possibly like science if they think that's good science. Don't bother redoing one of the most famous experiments in the history of science. Don't bother doing it. Don't bother proving your silly theory. Let's see, you understand a parasocial emotional attachment to Gary. Oh yeah, you're just talking shit, fella, so yeah, goodbye. You're just a waste of time. Fuck off. God damn, people can't stand the goddamn... Make a physics argument or just shut the fuck up.
Because what gravity's doing is it's bending and warping space-time. So what this means is that time...
Except for the fact that it's always making things hot. Always. They're always hot in the center. They're always molten in the center. They're always big objects. That's what's causing the gravity, the absorption of the heat, the motion of electrons and protons.
Travels.
And it's absolute heat. It's not heat on a Celsius scale. It's heat on a Kelvin scale.
Slower in Greenwich than it does in Boulder. And the difference is about 5.6 microseconds a year. So what I will say is that you are aging faster than me.
I am, but relative to who?
So obviously these are undetectable, silly, nonsense little statements. It's such a minute amount of time you can't even barely measure it. So it's just ridiculous to have this conversation about how it spent less time in the universe. No, it didn't spend any less time in the universe. And all you did was take a clock that is measuring its vibrational, essentially its size. It's oscillating based on its size. and all you're doing is putting it in an environment where it's getting a little bit pushed more in one direction than the other, so its shape changes a little bit. So you're taking a cesium atom and you're playing with its shape. When you move it very fast or when you put it in heavy gravity, its shape changes a little bit. And so it changes its resonant frequency. And so it's the clock that's broken. It's not goddamn time that's broken. I mean, why conclude that the thing called time is broken when, again, to break time means you have to break the function of the universe. You have to extract the photonic energy from around something. If you're going to put something in some fucking special frame where time doesn't happen at the same rate, then somehow you have to stop the universe from getting inside that frame, and you can't stop the universe. You can put a wall instead of a window, right? If you had a window, you can look out. All of this relativity shit goes away, right? Because everybody sees everything swooshing by at 1,000,000 miles an hour, and they say, oh, okay, I'm obviously time dilated because the universe is buzzing by. But the fact is the window is irrelevant because you know the fucking energy is already in the universe. It's traveling right through the side of the fucking goddamn spaceship. The gravity doesn't stop at the wall of the spaceship. The photonic energy doesn't even stop at the radio waves get in. Lots of things go right the fuck straight through. So this is a whole big nonsense theory that you can somehow isolate yourself from the rest of the universe. You can't do it. You can't have your own little special time frame. It's crap.
Because my proper time is going to feel very normal to me.
You sure?
Meaning the time that I'm looking at, I'm looking at my watch, it all feels normal. But if I could somehow look at your watch,
Yeah.
I would notice that it was running behind.
Uh-huh.
That's because you're closer to Earth's center of mass. Gravity is stronger where you are, so time runs more slow.
So just understand what they're saying here. They're saying that somehow her watch is getting hit by a different number of photons. There are different interactions with the universe. That somehow she's having less interactions with the universe than he's having with the universe. That can't be true. It's just idiotic to say I'm going to speculate that that's the truth when there's just no evidence that indicates that actually happens in the universe. That somehow the density of energy in the universe isn't consistent. I mean, the background radiation points to its consistency. It's all kinds of evidence of its consistency. And the inconsistency would be random. It wouldn't be specific. So again, it can't matter. Even if you were in a place that had fewer photons, it wouldn't mean that time actually changed any.
I mean, this stuff is so
it's mind blowing, it's mind warping, it's space time warping, but it's also experimental.
Oh, it's just such a religion. I mean, it's just so sad. It looks like a religious kook, and that's all this is. It's just religion. Physics is just a religion. It's not science. They prove none of this. Again, how many times do I have to say, where is a shred of evidence that it takes 25 times the fuel to spin something 5 times as fast? Not a shred of evidence indicating that could possibly be true. And it's the foundation of their energy theory says it must be true. And it's idiotic. On its face, it's idiotic. And I have to make videos for 10 fucking years saying this shit. Because these people are just fanatic religious fuckheads. They won't even listen to the counter argument. I can't pay them to make a counter argument. I mean, they're just so full of this goddamn goop, this shit theory. And they sit there and steal the word science and put science label on this fucking goddamn stupid Muslim religion. That's all it is. It's just Muslim babble.
Confirmed.
Absolutely.
And that's, I think, something that we should pay more attention to when talking about, because it makes it seem more real. Like, they've done these experiments.
Oh, fuck. I mean, it's just amazing. No, you've done shit of experiments, and every time you do an experiment, you just lie about how to interpret it. You interpret the double slit, you talk about 2 waves. 2 waves don't mathematically work, unless you have infinitesimally small slits in which waves can't even get through them. But there's no mathematical consistency with the actual mechanics. If it was actually in the center, if the wave centers were actually used in the math, the answers won't be correct. You sit there and say you threw electrons at a crystal and you call it a 2-slit experiment. There's no fucking slits. Yet you call it a two-slit experiment. I mean, you're just so full of shit. You know, you've proven, you have experiments. None of the experiments are direct. None of them are, lack 4,000 million variables, 10 million black boxes where you say, oh, this is where the photon is split in two pieces and then divided by 5 and then multiplied by 7 and then something else and then turns green. You just make up a bunch of crap about what you think happened in the box. Ugh. I wonder what audience this stupid show is made for. Ugh. Jesus, all this babble, and they haven't said a damn thing about how gravity really works. That it's time dependent. It's just like paint spray. Okay, it's just like rain. How long you're in it will decide how much you get. Let's see. Let's see. Better delete that comment because you're getting banned. Yep, that's what he got. Is there any discussion anywhere on the internet of why push gravity could not work? Yes. Push doesn't work because of drag. So the simple argument is that obviously if you're going forward, you're going to bang into more force this way than you this way. And so it's going to eat your velocity because you're moving into more force theoretically. But the trick is you're not really doing that. So it's like, well, if the Earth is, rotating around the sun, you could understand that the Earth's velocity stays constant. It's never eaten away. But if it was banging into more force this way and less force pushing it, then obviously it would have to slow down. But the trick is that you can't create more force in front of it and less force behind. Because as soon as you slow down, you'd recognize that the force pushing from behind that was missing you is all going to show up and hit you. It's going to arrive at its location, and you can't evade that. And the same is true for the extra force you plowed into. Well, you just plowed into it sooner. You didn't change the fact that it was going to hit you. You just got to it sooner. So as soon as I equal the time, as soon as I make the time catch up, that is, I stop you moving, all of the forces end up being equal again. So you can't really escape it. So the fact is what you would do is you're moving. Your atoms, your electrons and protons will move and then sort of stop and then move and then sort of stop and then sort of move and then sort of stop. They don't move at a constant rate because the fact is they slow down, they get dragged, and then they get pushed again and pushed and forward. So they constantly are changing their real velocity. But anyway, drag is the big subject. That's the big killer of particle gravity, push gravity, is the fact that whatever's doing the pushing is in the universe, and if you're moving, you're going to hit more of it in front of you than behind you, and therefore it's going to eat your velocity. But if you really think about the subject, you can recognize that there's mechanisms that defeat that notion that you actually could drag yourself to a halt, because you can't change how much force you're in. That's sort of my argument here. You can't change the total amount of force that will ultimately hit you. So as soon as you stop, you understand everything that wasn't hitting you will catch up, okay, and you haven't actually hit more force going forward, but it's the same amount of force, you just hit it sooner.
They've taken really accurate clocks and put them up at high altitudes and down at low altitudes. And
so really accurate clocks as long as you don't jiggle them. Yeah, as long as you don't push them in a force. As long as you don't throw them in the river. So obviously the argument is yes, all these clocks are all built on technology and all of them are vulnerable. And it's just silly to say you've made an invulnerable clock, because everybody knows that atoms can be broken. If you can break an atom, you can break a clock.
Seen that this exactly happens, that time runs more slowly on the lower clock.
But we should also be said, we're not talking about like stopwatches here, right? We're talking about like atomic clocks,
Yeah.
which are, you know, like based on the most precise measurements that it's possible for humans to take with the technology that we have at the moment. And the calculations, they're not just like close, they are like dead on
They're
the
dead
nose.
on.
All right, so they're not dead on. So all of the GPS stuff isn't done with anybody's equations. They just turn the knob until the times equal each other because it doesn't work that precisely. So they're just talking shit here.
If Einstein had had these ideas in the 1200s, confirmation would have eluded them for a long time.
I mean,
So again, they think they've confirmed it because they make a clock that's affected by the circumstance of how much pressure it's under, you know, how, in a way, hot it is, how much it's thermodynamically interacting with the universe. And again, so that because you put it in a differential, okay, and you've got more force pushing it from one side than from the other side, you're going to claim that the clock is immune. And that's their claim. So you have to believe the clock is immune to believe their story.
the idea of 5.6 microseconds a year is like, you just don't really notice it, do you?
You wouldn't notice it.
No.
Yeah, he would have been seen as just a guy writing some cool fairy tales.
Yeah. What?
And why would they be cool fairy tales? That's the part that still eludes me. Is Hansel and Gretel, Gretel? Yeah, is that a cool fairy tale? I never thought it was all that cool. I didn't think it was anything but, what the fuck are you talking about? Yeah, so I don't get it. Sorry. I don't find these silly little tangential fairy tale roads you like to travel at all interesting, compelling, or fun.
One thing that I do think is interesting, though, is that, as you said, right, this is the canvas that we're living on. It's not something that we're noticing. And actually, they've done these different experiments where they've taken earthbound creatures, right, and taken them up into space. You know, not just humans, but to see how they behave and how they react. And fish, in particular, there's something interesting that happens. If you take earth-born fish up into microgravity in space, the ISS or whatever, they're completely disoriented. They sort of don't know which way is up. They're like really struggling to swim. They're just, they don't have a good time. But they can have babies in space, right? And they have managed to breed them. When the babies are born, right, these kind of little fish eggs hatch. Those babies, absolutely fine. Totally chill about it.
Interesting.
Okay, so the only thing you learn from that is obviously your brain orients to the world, so the same thing would happen to us in terms of we could relearn how to interact with gravity if we were born. So if we could born a human into, what do you call it, free fall, zero gravity, they would have the same. It would have the same effect on them in the sense that their nervous system would interact with what you're giving them as an environment. And so they're going to learn the new gravity formula instead of the one you learned. So that's not all that interesting. We're programmed to the environment we're born into, and that's what programs us. And that's why you have to learn how to do all these things. So a fish born with no gravity will learn to orient itself based on the world that doesn't have this gravitational effect. But I still don't understand how exactly doing fine would look like, because the water pressure, I guess, well, they synthesize the water pressure because they have to have air pressure and all that. So yeah, so that's okay.
Swim back normally.
Do fish come into the world as a blank slate, ready to learn it? And if they learn gravity, then they can't forget it?
Well, I think that's the hypothesis, right?
Yeah, it does. So it's not even an interesting subject. Why is this part of? This isn't a physics conversation. It's a biology conversation. And it really doesn't have anything to do with gravity. It just has to do with how a mechanical system orients to its environment.
Right?
Yeah.
But they also did this with octopuses, octopi. And the octopuses that were born in space seemed like they were fine. And then when they came back down, they really struggled. They struggled on Earth. Yeah.
I feel bad for those.
I know.
And now here's like where you're supposed to be living, and there's gravity, and it just feels
Right, so we torture animals all the time for, really trivial pursuits, and that's really tragic. So you just wonder about how many animals were burned up in all the rocket programs and experiments and everything else. It's all kind of disgusting. But whatever.
like an oppressive force squishing you all the time.
Exactly.
You're welcome.
It would be so much worse that way around, wouldn't it? Right? If you go, I think I would rather be born in high gravity and move to low gravity than the other way around.
These poor water animals that we're subjecting this to, it's harder for them. For us, we need that gravitational force for our bones to develop properly. A human baby born in space in the so-called zero-G weightless environment, their bones would not grow properly. They would look like they had rickets. I did a video about this, and it's very gruesome what would happen if you tried to grow a human in with no gravitation.
I think he's making that up, though, frankly. So, I mean, they haven't tried it. So, yeah, it's just talk.
Tension on their bones. I mean,
they must have done it with mice by now, right? So they grow really fast. So are they saying that the mice don't grow bones correctly? I don't think that's true.
Tried this with rats.
Oh, there you go.
As well. Birthing rats in space. And yeah, they did.
See, look what they did. This is a conversation about what the fuck gravity is, and they've turned it into some gushy human conversation about what it's like.
Do too well in space. They really need that landlubber gravity
in order to form properly.
Yeah.
I mean, some science experiments aren't that nice, are they?
No, they were all okay, by the way. This was just like a minor inconvenience, and now they've got a good story to tell their friends.
Yeah.
All right, so one minute he says their bones are all rickety and fucked up, and the next minute he says, oh no, it's a minor problem, not a big deal. Which one is it?
Is how I choose to look at it.
It was worth it for the anecdote that they got.
That's right.
Yeah. These visualizations of warping of space-time, though, I mean, should we talk about those a little bit? Because I think there's some that are quite common. You see them around a lot, right? Like I sort of even use for myself there, the stretched rubber sheet with Earth as a box.
Right. So it's a two-dimensional diagram that needs gravity to work. And it's really just a bunch of rays going into the Earth. It's a bunch of vectors like a light bulb. It's a bunch of vectors flying out of the light bulb. I mean, come on. Damn it. Not that complicated. So obviously all these images of bent fabric is bullshit. It's not actually what the gravity has to be doing because the gravity's working in 3 dimensions. So they're using 2-dimensional models to illustrate a 3-dimensional function that can't be bending a fabric. That's just a bad analogy. A really bad analogy.
Bowling ball sitting in the middle of it. I mean, they're kind of useful in a way, but they're also quite limited because
they're outright deceptive. You can't use gravity to explain gravity.
Ourselves are not capable of comprehending these extra dimensions.
Yeah. I've never really liked...
So this dimension word is just such crap. There's 3 physical dimensions. If you want to talk about some other thing being a smumension or a zemension or whatever, a conmension or something, or so you want to call it something else, fine. But there's no point in using the word dimension. Because there ain't none. There's 3 and that's it. Use some other word for some other concept. I would argue time is just a function, and it's just a byproduct of the fact that there's no instantaneous movement.
The rubber sheet analogy, because it doesn't seem to do anything but just show what you already feel, which is that gravity makes things fall. They rely on gravity to demonstrate gravity.
Yes.
And also they're shrunk down to just the 2-dimensional plane of a sheet of rubber. We're talking, of course, of the demonstration where you've got a rubber sheet, you put something really heavy in the middle, and it sags. And then when you put like a little marble on it, it rolls down towards the big, heavy, massive object. And you say it's because of gravity. Of course it's because of gravity. That's why everything rolls down.
Well, you try and get a gravity-free situation on Earth in which to demonstrate.
Yeah, and then also you can take a marble and you can throw it out tangentially towards the slope, and it'll orbit the heavy object, go around and around, but it loses energy so quickly. It always spirals into...
Exactly. It always does what gravity fields don't do. That is, if you don't crash into the object and you don't hit anything to change your speed, you're just going to fly out of the gravity. So there's only two choices if you don't collide with anything. You either collide with the thing in the middle or you shoot back out. That's it. There's no orbiting. The only way you can orbit is something that has to change your speed. You have to hit something and have it change your speed. So that's another way it's very deceptive. It's full of friction, obviously, and there isn't friction in space, so it's obviously very deceptive on its face. And there's no other way to illustrate it except as some sort of magical vacuum cleaner that vacuums in all directions. And what is it vacuuming? Some kind of nothing. And somehow everything's moved into nothing. It's just a silly, stupid theory.
The thing, and I just feel like especially for students, they go, well, but Earth isn't doing that. We aren't spiraling into the sun, so clearly I'm not learning anything about Earth and the sun.
Yeah, it's where the analogies break down.
Yeah.
Right. So they break down, they're really no good, and yet they're shoving that crap in the face of kids all the time. That's the only way they show kids how gravity works. So they know it's a bad analogy. It really isn't the truth. It really isn't how it works. And yet that's what they teach all over the fucking goddamn world. I mean, it's just amazing. This is scientists conceding the science they're teaching is garbage, and, well, we ain't going to fix it. So what? It's bad. So what?
One that I do like, and I think this was Richard Feynman, was he was saying the reason why it's difficult for us to imagine additional dimensions, if you take a piece of paper and you imagine that you have an ant living on this piece of paper, and the ant is so small that it's effectively two-dimensional, right? It cannot conceive of up and down, because even when it climbs up a wall, the curve between, or the corner between, the ground and the wall it's so tiny that it's like, it feels like it's just this continuous surface.
Yeah.
But if you take an ant on a piece of paper and you say, this is point A, this is point B, and you ask the ant what's the quickest way between these 2 points, the ant's going to say, oh, it's a straight line between the two, right? Which is like, yeah, great, well done, ant. But you could take that piece of paper, and because we have an additional dimension, we have 3 dimensions, whereas the ant only has 2, you can fold the piece of paper and make A and B combine in the same point, right?
Right, but you can't do that with any of the 3 dimensions. So there's no magic to the 3 dimensions. They can't be warped or bent or any of that crap. So again, they're real dimensions. You have to travel the real circumference of the Earth, not some straight line. It's just such bullshit.
Effectively create a wormhole that the ant didn't see coming. And this is sort of a way to explain why this stuff is so difficult for us.
I don't think Feynman invented wormholes, so I think she's got that wrong.
To comprehend, because once you bend that canvas, once you warp that curtain, I mean, everything sort of changes. The rules slightly go out the window.
Yeah, and that analogy is great, but you can also see how hard it is to jump up to where we live.
Yeah.
Because I can imagine a curtain folding and things that live on the curtain not understanding. But how do I bend 3-dimensional space, not a flat curtain, but...
Yeah, exactly. You can't bend it.
Like a whole universe. Where am I bending it into? Some other dimension.
Yeah.
Oh, so more baby talk about another dimension. There's only room for 3. You can't it's all right angles to each other. There's no geometry for a 4th dimension. They're just pretending somehow there is when there isn't.
Well, a 4th spatial dimension.
A 4th spatial dimension.
Have you ever tried to visualize a 4th spatial dimension?
It's not about visualizing. It's about the rules. It has to have right angles to the other 3 dimensions. It can't do that. So there is no visualization. You can't draw it. You can't mechanically make it. It can't happen. It's not possible.
A 4th line that could be perpendicular to 3 others?
I mean, you can't, right? You can only imagine slices of it. You can only imagine
So
3-dimensional slices.
You don't think it's possible?
I mean, you can describe it mathematically. That's like very easy. I mean, for instance...
So you can't describe it mathematically because all you're doing is making up. You're just saying there's X, Y, Z, and W. W? Where'd you get it from? Yeah, you can make up a W and sit there and pretend your equation has some relevance and they're somehow connected dimensions, but they're not. You won't get right answers for anything.
You know, you could take like a square, right, or a cube. I could tell you the corners of a cube are there's one at 0, 0, 0, there's one at 1, 1, 1, there's one at 1, 0, 0, and so on and so on. And then if I use the language of mathematics, then it's really easy, right? Because I can just say, well, four-dimensional one, it has a corner at 0, 0, 0, 0.
Yeah, you got 4 coordinates. Fantastic. I'm still not...
Yeah, exactly. You just added a 0. You just added a fake idea that doesn't have any meaning or significance.
feeling it.
You're never going to feel it. You're never going to see it.
Why do you think I can't?
I just don't think that your brain is capable, and that's not just you,
This is,
Michael.
you know how a lot of people count sheep.
So again, why would you even talk about something that breaks the rule of the definition? The definition is the rule, the right angle rule. It can't be done, so why pretend there's such a thing? There's no fourth spatial dimension. There's no fourth dimension because the word dimension has a specific rule. It's terrible science. This breaks vocabulary. Let's see, is there any discussion anywhere? Oh no, okay, it's an old one, so no new comments. Let's see how many viewers there are. See how long I'll hang around. 4, that's pretty bad. Yeah, alright, yeah, 4 viewers isn't much. So maybe I'll call this enough of a video. Let's see, what time do I, yeah, well, I can play a little bit more.
When they go to bed, I try to imagine a way to look inside a hollow sphere.
Right, so I do this every night too. You know, I always try to orient my dream sequences to do science for me. But unfortunately, it's pretty, it's like 20% of the time it works, I guess. It works in any kind of real way. Because it always becomes some sort of competition. And so, you know, the fact that there's all this animosity and competition between people, that infiltrates it. And so then it ends up like we're playing darts or something, you know, or some challenge, and I have to successfully navigate a maze or some other thing. So it becomes very abstract from the, you know, specific physical concept I'm trying to imagine. And so that's kind of annoying. But, you know, 20% of the time it does work, and I actually think of something, and it's a good idea, and blah, blah, blah.
By looking from a fourth spatial dimension. And I haven't succeeded yet.
You surprise me. All right, well, I hope we've suitably warped your minds. Should we go to a break?
Yeah, let's do it.
Make lunch with me while I tell you all the things I do not do with my money and why you might be struggling because of that. The first thing that shocks a lot of people for some reason is that my house is only 800 square feet.
What the fuck is the break? You're gonna do a commercial?
All right, welcome back from the break. We've talked about Newton and Einstein's theories. Where are we now?
Okay, so here's the thing, is that everyone was like, Einstein's such a genius. Everything's stitched up. It's all great. No, there's still so much more. There's still all of these big questions that it's like, why? It doesn't quite work. It doesn't quite work. So one of them, there was a cosmologist called Fritz Zwicky, one of my favorite cosmologists of all time.
It's a good name.
It's a great name. And also, he was a proper curmudgeonly old git. He wasn't a very nice guy, right? And he had a saying where he would say of his colleagues that they were spherical bastards because they were bastards from whichever angle you looked at them.
Ah, very clever.
I mean, he is a super smart guy.
Yeah.
Anyway, he was studying this galaxy, the Coma Cluster, and he was like, well, you know what? Something's going on with gravity here. Something's not quite right. Because these galaxies are spinning around so fast that if the only gravity that's present is the gravity that's coming from the stuff you can see, then these galaxies should be spewing stuff out, right? They should be ripped apart by the speed that they're spinning. And so
All right, so this is just the more the crap because they presume gravity is only made this one way, the center of mass. So they're doing this center of mass thing. So they're taking this whole... I mean, a galaxy is nothing like a solar system because a galaxy has mass on both sides. It has mass in all the, dimensions of the plane of material. So in a sense, it's objects rotating around each other's orbit. It's not things that are rotating around the center of mass. They're rotating around each other. So their gravitational pull is based on the entire amount of matter, in that plane this way versus the plane in the other direction. They're part of, you have to think that a sun in a galaxy is inside the Earth. It's part of the Earth. It's not on the surface of the galaxy. And they're measuring these gravitational influences based on the distance from the center, when no, you have to measure it from their distance from all the other mass in the galaxy. And the fact is they're inside the object. They're not outside the object. And that's a huge difference in terms of how you calculate the gravitational forces. So I think they just got it all wrong. And then I'd also argue that they don't really know whether a galaxy is getting bigger or smaller in any one moment of time. And so I would argue that over the billions or trillions of years the universe existed, that all the galaxies are doing is just changing their shape a little. They get a little bigger, they get a little smaller. They get a little bigger, they get a little smaller. That's why the velocities are not orbital velocities, because gravity is actually changing over time. The bigger galaxies get, the more they expand. Well, that means there's more energy in the field. That means there's energy to compress them again. And that's what they're dealing with. So the whole Big Bang theory, I think, is just bullshit.
A number of other cosmologists were like, okay, something is not adding up in these equations. There's something that's not right here. And so rather than kind of going back and undoing Einstein's versions of gravity or undoing Newton's, they were like, well,
you don't have to undo anything except your understanding of the mechanics of motion inside the galaxy. And there's no reason to think these objects are orbiting. You can understand that there could be moving in or they could be moving out.
So they look like they're right. So maybe what's going on instead is that there's all of this other stuff that we just can't see.
We can't see.
So it's like matter.
All right, so now they're going to, instead of talk about gravity, they're going to talk about this silly dark matter that has gravity, but it doesn't reflect light, doesn't absorb any energy. So again, not absorbing energy, and yet it has gravity. So again, that's obviously, from my point of view, super, double, triple ludicrous, because the only reason why there is gravity is because of the absorption of energy, not the transparency to energy. If you're transparent to energy, you can't absorb the energy, you can't create a differential, I can't fall in your gravity then. I mean, it's really just so simple, and they've made it such a convoluted pile of mush.
That's like not reflecting light. Maybe we should let's just call it dark matter, add an extra term in our equations.
Exactly, just make up a holy ghost, and that's all it is. It's not even, I don't even know what it is. It's archangel, I don't know what we want to call it. It's Thor. Okay, just to invent a fake god, okay, to fill in the void, because God is, he takes every third Friday off. You invented a substitute teacher that shows up, and we'll call it dark matter. I mean, it's just such crap physics. Just made up shit. It's a fable. It's a hobgoblin. It's a pixie. It has nothing. It's nothing to do with being real. Okay, it's underwear gnomes. Just invent some nice, funny little fake character to fix what's broken.
Everything good, everyone can go home.
And that's the birth of dark matter.
That's the birth of dark matter, and frankly, how dark matter has long remained.
Wow. I didn't know that Zwicky was also part of dark matter invention/discovery. We know a lot more about dark matter today.
We do.
Amazing. I mean, they're talking about it like it's real. Like this fake, made-up fable has something to do with reality. That there's actually this stupid shit in the universe. And there's just no reason to believe this crap.
Still haven't found it.
What does it mean to find it? Like, what would it... I was going to ask what it looks like. It doesn't look like anything. It doesn't interact with light. But could you...
Oh, well, I guess it should look like a black hole. It should be discrete clumps of matter, so you should be able to see things being affected by the gravity it's creating. in some sort of micro sense. Instead of the macro picture, you have to look for a place where you can see the macro picture and see if you can find something where something's orbiting this dark matter. Okay.
Have a jar full of it?
Yeah, I mean, I'll be honest with you, every jar you've ever had has probably got some dark matter in it.
But there must be a small amount, because there aren't a bunch of gravitational anomalies caused by this invisible matter in our day-to-day lives.
Yeah, but it's here.
So dark matter.
Now, what can I say? It's here because we say so. We are going to tell you a silly story, and you're supposed to just believe it because we told it to you. It's just Goldilocks. It's Red Riding Hood. This has nothing to do with reality.
Matter, though, the actual substance that's in the universe and around us is still very mysterious.
Still very mysterious. And there's other things that...
I mean, it's just so... I mean, we've taken all these atoms apart. We've chewed them to pieces. We've tasted them. We've licked them. We've snorted them. We've done everything we can to all these little molecules. We know there's only 100 of these, 80 of these stable arrangements of a nucleus, plus the isotopes. We found the rules essentially, and there's no room for this, whatever this fake crap is. There's no room for it in the model. You can't make an atom with dark matter in it, positrons in it, taus in it, kubels, bobble wobbles, weeble wobbles. I mean, they have all this shit in there. There's no way the thing could ever function with all that crap in it. I mean, they've made a simple story so fucking convoluted and silly. And they're so pretentious, like we did something marvelous because we made up a hobgoblin story. Shit.
Mysterious here too, right? There are other things that gravity doesn't totally explain. I mean, Newton, in a way, sort of wrapped up what gravity is doing at the scale.
So again, they predicted where other planets would be found. They did all kinds of stuff with this gravity theory. And then she's saying, oh yeah, it has all these holes in it. No, there's no holes in it. It works really, really well. It's really complete. I mean, if it's 999% of what you want a complete theory to look like.
Scale of humans, right? That's sort of the scale of us wandering around.
And how to write formulas about it and predict what its effects will be.
And you get really accurate predictions at the scale of kind of humans. Einstein then did it for the scale of galaxies, the scale of solar systems, amazingly accurate predictions for that.
Well, it's the inverse square law, for fuck's sake. I mean, there's nothing to predict here. It obeys this simple law, the inverse square law, and you can do that by just turning the force into clumps of force and just count the clumps that hit you.
But what we still don't really understand is how gravity works down at the level of particles. Because this...
Yes, right. Well, exactly. Because then it becomes charge, frankly. It's electrons and protons. And the electrons and protons, if they're moving in a direction, they're not going to absorb force in that direction. They're just going to lose their velocity. If they're not moving in this against the direction, they're moving with it, then they're going to collect force. And if they get hit by... There's got to be two kinds of force because there's two kinds of matter. So if an electron gets hit by a proton force, it turns the force into an electron force, and vice versa for the proton. And with those simple rules, you can make attraction and repulsion for negative and positive objects, and you have basically north and south. You have magnetism. So electricity and magnetism are really the same thing. They're just expressions of the same function, which is charge. And once you can make dipoles, a neutron, an electron and proton close together, you've made a magnet. And now if you arrange the magnets all in the same arrangement, then you're going to have force patterns that are going to create magnetic fields that other magnets can see, or other elements that can arrange themselves as a magnet will see. I mean, it all fits together, but it's all elemental and simple. The small universe is a simple universe. It is not this complex, wavy, mushy, fieldy bullshit-averse.
Some weird stuff about it, right?
Right.
You have all of these forces. You've got the electromagnetic force, you've got a strong nuclear force.
Right. The strong nuclear force is negated by just simply understanding that you could have an electron, a proton, electron, proton. So you have that little thing called a deuteron. And you can understand that, oh, obviously I got the protons really close together because I just stuck an electron between them. I don't need a strong force. If the two positive objects can't see each other because I stuck an electron between them, and what they're seeing is something, that is absorbing force that's letting them fall towards, obviously they'll get very close together. And if I knock that little electron out, you could understand the two protons are now very close to each other. They hate each other. They're multiplying the force because all the electron force is being turned into proton force between them, and there's a tremendous force pushing them apart. So there is no special thing called, some sort of nuclear internal strong force. There's no such thing. There's just the force, and there's the functions of electrons and protons, and it's the identity of electrons and protons as two opposite identities that are creating the motion. It's their properties that are causing the phenomenon, not some special new force.
Which is the thing that sticks atomic nuclei together. You've got the weak nuclear force, which is what's responsible for radioactive decay. But each...
So again, more nonsense. Like they know something about radioactive decay, which is the breaking of the geometry of a nucleus. And like they somehow know something about how this functions. They don't know shit about it. They think that there's something called a half-life, which doesn't mean anything because, frankly, if I crowd the little atoms together, they'll start half-lifing at half the time or a quarter of the time or a tiny percentage of the time. So if I shove a whole bunch of uranium together, it goes from having a 10,000-year half-life to having a 10-minute half-life.
Each of those have a particle that...
You're not a child, you're a man. So stop wearing so many layers to go outside and get the bearskin tactic
that does the job.
Right.
So the electromagnetic force, for instance, it's the photon that does the job. Like the photon physically travels between the emitter and the receiver.
And what does it do? Oh, it like everything else, it bounces off essentially because everything isn't getting hotter and hotter. So everything is just at equilibrium with the universe, and essentially, so anything, all my interactions, all the energy hitting me has to go back out somewhere because I can't keep it, or I would melt. So, the stuff hits me, and I'm just going to reflect it. I'm going to reflect some kind of weird pattern based on chemistry and what kind of atoms I have and how elastic they are and how rubbery they are, and it's going to throw the stuff back that hits me in a different pattern. And that's all that's taking place. But it's all the same amount of stuff. I'm not doing anything. I'm not emitting anything. I can't be hot until I've consumed energy to be hot. So I'm not creating any force. I have to consume force to emit force.
What's doing the work of that force?
Okay, which one is gluon?
Gluon is the strong nuclear force, and then the...
Oh, it's just ridiculous. The special frog particle. So the gluon means you shoot it out at something, it sticks, and then it pulls it towards you. So it's the frog particle, the frog tongue particle. A particle does that. The magical particle hits something, and instead of making it move the way it hit, it instead moves in the opposite direction, towards. And they just made this up. It's just complete hobgoblin science. There's no science here. Just bullshit. Alright, so there hasn't been a comment for 20 minutes, so I guess we'll concede the room is dead. Okay, so I will say that's enough for now. And I'll try to post a response video on, I'll just post a comment saying I made a response video, and we'll see how long it lasts, before it's deleted. But whatever. It'd be nice if these people could interact. But like I said, I've tried to email Vsauce and with no response. Offering money with no response. I don't know who she is, so maybe I can try emailing her individually, but who knows. It's just such... Physics is such a crappy, shitty, unevidenced mush science. And I shouldn't be the only person griping. It should be a lot more than just me on the I want to see it. Show me. Show me. Show me. There's a lot more people saying, fucking show me. Don't tell me. Show me. You're going to say you did an electron 2 slit experiment? Show me the fucking slits. Yeah, don't show me a crystal. Show me the slits. You stinking liars. Alright, anyway. Till the next time, and such and so forth and whatnot. Yeah. Have a pleasant whatever, blah, 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 blah. Blah, blah. Blah, blah.